Hi folks, evening, and welcome to my talk about the bad, the ugly, and the good, or about mutable, immutable, and observable data. Now you might be familiar with the first two, those are well-known paradigms, but I'd argue tonight that there's a third and better paradigm, and that is using observable data, or reactive data as some might call it. And that is what is used in example, for example, Vue.js, or in this case, we're talking about MobX. And so, just for recap, and you might probably be familiar with it already, but we're going to quickly recap on mutable and immutable data paradigms, and then we discuss observable data. And I also give a quick sneak preview on how you can use MobX 6, which is about to be released. So to kick off this story, I want to kick it off with this tweet from Decouple. He's quite a well-known guy, so you might know him. Oh, did I forget to introduce myself, by the way? So my name is Michel Weststrate. I'm the author of MobX and also of Immer, an immutable data library. And I'm currently working at Facebook. So, hi. Anyway, back to this tweet. So it's an interesting one, because it's excitement about hooks and context, and that it's so expressive. And that's correct, it is. And these are beautiful paradigms. But one thing it didn't solve, which was solved already, is efficiently rendering applications. And so that's why, in the end, he concluded, no, I'm going back to using MobX, basically because I don't have to bother about optimization anymore. And so let's explore that story a bit further today. So for today's talk, I built a demo application, and it's not like your typical to-do application, because to-do applications are bad demo examples, and I'll explain why. But this demo, it has a bunch of order lines and a bunch of exchange rates that apply to them. So in essence, pretty straightforward. But the interesting thing is that this demo has a cross-cutting concern, namely the exchange rate. So the state we have matches quite closely to the render tree we have, but not entirely. So for example, if we render an order line, that doesn't specifically and only depend on the status of the order line, it also depends on the state that is living somewhere else, namely the current currency, the current exchange rate. So this is a cross-cutting concern, and as soon as you have those, things get complicated immediately in the current paradigms. And other examples of that are like using tags, where you want, for example, change a tag and then it should update in all places, or locales. There's many examples. Most applications have those cross-cutting concerns. So in essence, the state is not a tree, it's rather a graph. And so let's model this with mutable data first. So here we have our demo application. We have the orders at the top, the exchange rates at the bottom. And so if I toggle something, you see that's like updates the UI, and the boxes you see, that's the React DevTools that highlight the re-renders. And so I can change the exchange rate, and we see that this is properly reflected in the UI. So how is that modeled? So here's the application. First of all, I put all the domain logic in a separate file. So here we manage the currencies and we manage the orders. And there's a bunch of straightforward updater functions that change the currency, change the price, add a new order, etc. Nothing really super complicated about this, but that's I separated the domain logic. That's what I like to do in general. And then I use the useRef hook basically to store the initial state. And I just hold on to that reference. It's mutable data, so that reference is valid forever. And then I have the special use force update hook, which gives me a render function which I can call, which forces the tree to update. It's kind of a hack, but it does the job. So then after that, I built up the UI. So there's orders, there's component to render currencies, and in the orders component, we map over the order lines. And this is actually the most interesting component we will look a lot to. So it renders the order lines, but also grabs the currencies from the context to be able to render that. So if you profile this application and I change the currency, just one currency, the euro, we see that all the rows are re-rendering. And the basic reason for that is like, when we call this render function, it basically says like, something changed in this application, we don't know what, so good luck with it, just re-render everything. So that's the most naive approach, and you can see why it is pretty bad. But it is kind of our baseline. So if you look at the components that re-render, if you picture that, it's basically everything, the entire tree. So mutable data is, in essence, simply, it's straightforward to write. It's also quite easy to test, actually. It's just like the problem is like, we have no clue what or when to render. So that's basically the essential problem we try to solve today. It's like, if you have state, how does it affect rendering? So we have to answer two questions. The first one is, what data, what state changed? And secondly, where is it relevant? Which components are affected? And so things get slightly better if you take a look at immutable data. And that's quite a common pattern, so you might be familiar with this. But again, I'm just going to recap it to be able to draw a comparison later on. So we're going to refactor our application in such a way that all our functions are pure. And so that they don't mutate data anymore, rather they all produce a new collection of orders with the update we intend applied. So we loop over all the orders, we spread them out, and for the relevant order we update the price. The currency update is similar, and also adding an order is now getting the old collection, spreading it into a new one with the new one added. And similar for updating the currencies, we now produce a new currency table. So when we have that, it means that we no longer need an ugly hack to update, and we're going to properly use useState. So we grab the useState hook and we pass in the same initializer function. So, and then we have to update our event handlers. So our event handlers now are going to take the current state, call those functions, get the new state back, and store that. And this will automatically trigger a render by React. Now, the nice benefit is that because like all these data structures are immutable now, is that we can start optimizing our components by wrapping memo around them. So we'll give them a little memo, they're set. And there's now one final thing we should do, is that we should also wrap all our event handlers and use callback. Otherwise, you get a new event handler every render, and that would invalidate all the memos. So let's verify. So everything is still working, so we can profile this. So again, we changed just the euro exchange rate, and what we see now is like, not everything is rendering, but almost everything. Most certainly, all the rows are still re-rendering, even the rows that don't use the euro exchange rate at all. And the reason for that is that like they still grab that currency table from the context, and that table is new if we update one currency. So they all have to reevaluate if that change. They all have to re-render basically because there's a new currency table. So, this is not the end of it, because again, we can optimize it. So at this moment, this is what our update tree look like. We change the currencies. The currencies is used by the order lines, so all of them have to redraw. But luckily, we can make this a bit smarter. So we can do this by making those components a little bit more pure. So far we grabbed the currencies from the context, but instead we want to get those passed in to the function so that they go through the memo function. So we want to get them from the parent. So rather than grabbing them from the context, we're going to pass them down. So we do a little bit of plumbing and pass it down here as well. Then it can apply prettier. And so now we can do something interesting. Because now the thing is passed through memo, we can make memo a little bit smarter and basically tell it to only update if a relevant currency did change. So we can skip re-rendering even when we receive new data if the order is still the same object and the currency is still the same object, or if the currency changed but not the currency we're interested in. So we grab the exchange rate from the order and we compare that with the exchange rate in the new currencies table. If that's still the same, then we can still skip rendering even though we got a new table. And so this was the old problem. Let's profile again. Profile again, and we recorded one update. And now we see that like the rows that aren't using the euro exchange rate didn't re-render either. So that's pretty good. But the sad thing is though that like now the table that like holds all the order lines is still re-rendering, and it's actually an even more expensive component. But it has to re-render basically to be able to pass that currency table down. So actually properly optimizing this is even more complicated than this. So what you could do is create a wrapper component that like just grabs the currencies from the context and pass the ID of the order line you want to render through, and then have utility component to the memorization. And so actually properly optimizing this with those cross-cutting concerns is still pretty tricky if like not all the updates are relevant. So this is basically what we ended up with. Let's switch paradigms. So this immutable data stuff, it's a bit harder to read and write than the original thing we had, especially because like the code you write doesn't match as closely your intention anymore. Like you intend to update the currency, but you actually write an entirely new table. But it does allow for manual optimizations and memorization techniques. So we can get better results with this. It's far better than using mutable data. But so when we look at our original problem, we can determine quite effectively what changed by doing reference comparisons. But it's still hard to determine where it is relevant. And so that's why we ended up writing this custom function or custom selectors if you use, for example, Redux, to figure out whether the change is actually relevant. So let's go to observable data. Now the idea behind observable data is actually pretty straightforward. It's basically like building spreadsheets. And so the idea is that if you render some data, if you render some field of an object, you subscribe to that field. And that means that like in the future, if one of those fields is going to change, that field update will notify exactly the observers that were listening to the change. That might sound a bit complicated. It's easier to demo actually. So let's go back to our code. And what I'm going to do is I'm going to stash the changes I've made so far from the mutable stuff. So we're back at the mutable version because that's an easier starting point. And from here on, I really only have to make 2 changes. So this is again the ugly hacked rendering. These are the simple original functions we had before. And so I'm going to import useLocalObservable and observer from MobX React Lite, which I already installed. So useLocalObservable, that's the one I'm going to use to basically create an observable object local to the component. So I again give it the same initialization function, and now I'm going to throw away my hacky re-rendering. There's that. And there's only one thing to do. Rather than applying memo to a component, I'm going to apply observer to a component. And that means that this component will automatically subscribe to any observables used by its rendering. So let's wrap them. Okay, that's all. I changed two things. I put the mutable state in an observable, and I wrote the components with observer. Everything still seems to be working, so I didn't make any mistakes. Okay, let's profile this. So this was the old, the new, again, changed just the euro, stop profiling, and ooh, this looks good. Why? Because it updates very few things. So it updates the exchange rate table, which makes sense. It updates the total component that shows all the total amount, and it updates only two rows, the ones that use the euro, and it didn't update any of the parents. So effectively, with very little work, this is now what our rendering graph looks like, and it's way, way, way better than what we achieved before, even though we had to do quite complicated stuff there. And that is because observable data solves this problem. A, we know exactly what changed because it's detected on a per field basis. And secondly, because it subscribes automatically, we know exactly where those changes are relevant to which components. And so observable data is in essence pretty straightforward to write and to read because we just use these same APIs as we did with the mutable data before. But we get very smart and more rendering out of the box. And also it allows for very easy separation of concerns, but I'll discuss that later. First, let's take a bit closer look into MobX. So I introduced observables. I'm going to introduce a few more concepts. And first of all, I'm going to restructure what we have for our domain logic a little bit. And what we did so far is completely fine. The rest of this restructuring is just a personal opinion. I like how I like to restructure things, but MobX doesn't require you to do that. It's just I like it, and I will explain why. So I have all this wiring with event handlers, and I have all those individual functions that do the updates. And I noticed in big teams, these kind of utilities are quite hard to discover. It's way easier if you have those methods available to the objects. So I had this change on my clipboard. And so what I'm going to do is I'm going to create some factory functions that create observables and do that rather here in the domain place than where I did it previously inside the components. So I create a new observable using a new API, make auto observable. With a few fields I have, I make the computation part of the object as well by using a getter, and I expose two methods, set price and set currency. So these are fields, this is the getter, and these are the updaters. Right, and I close over the currencies so that I can compute them. And then I created an order store, which has orders, which has computation for the total amount, and a few methods to add some orders. And for demo, again, I put some initial orders in there. So why did I change this? Well, I like it because it removes the responsibility of creating observables from the component. So I'm going to go back to using good old useState. But note that I don't use the updater function. I just create the state once and then the reference is stable because this is observable data. So I never have to replace them. And so now I throw away all the event handlers. That's what I like about it. So rather than passing all those event handlers down, what I'm going to do instead is I make the API a little bit simpler, and I'm going to hook up the event handlers directly to the methods exposed on the order. So I can call set price and set currency, and I can directly grab the price and pounds from the order. And so, and if I were using TypeScript here, which I normally do, this would autocomplete very nicely. And here for the currencies, I'm even going to directly update them in the event handler. This is really an anti-pattern. I just show you that it works. So yeah, this still works. It's basically the same. So why did I do it? One is to pay attention to a few interesting details. So one is that if you think about state and computations, that computations are like kind of a render tree where you render values rather than components. But it's also a tree. That sounds a bit vague. Let me draw a picture. So if you think about the order price, that computation depends on three values: the price of the order, the currency of the order, and the exchange rate in the currency table based on that currency. So three observable values that influence the output of price in pounds. Now those computations, basically you can see them. You can see this diagram as a tree. And so what happens if one of those chains, computation will be rerun, a new price in pounds will be computed, and if that changes, that will in turn notify the component that is rendering the data. So effectively, those intermediate computations, they become caching points for MobX. And so you can imagine that for the second order, you can draw a similar diagram, but then there's something interesting. If we render the total amount of the entire order, that depends on the store.order total computation. And so if those price in pounds change, but the order total in the end doesn't change, it won't notify it. And if you look at this diagram backwards, so you start from here, then you see that there's basically a dependency tree being built up. So total rendering depends on the order total, its output is cached, and that in turn depends on the price in pounds of the individual orders, and those in turn depend on the state of the orders. So this has a few really cool properties, as I will show you in a few more demos. So imagine, so here you can see that the observer is tracking the order, that is tracking what's happening in the order price, and the order price depends on the currency stable and the price of the order. So that's what I just showed you in the graph. So if we profile this and we're going to change the exchange rate of rupees, something interesting happens. Because the rupees is not relevant for any of those order lines, no order lines are re-rendering. So you see none of them are getting re-rendered. However, after that, we changed, in the second click, we changed the euro exchange rate, and then we see some items rendering. So you see really that this dependency graph is being built up dynamically. And I can give you another example to demonstrate that. So imagine that we don't want to show the exchange rate for large orders, because we rather have our customer call us for a custom quote of a better exchange rate. So that's what we changed now. So we made this conditional. So now it will show for the large orders, please call us. So for any order larger than 500. So that's what you see. So the interesting thing is now, if we profile this and we change the exchange rate of the Australian dollar, you see that the order line, even though it's using Australian dollars, it still isn't re-rendering, because at this point the exchange rate doesn't matter. It's using an exchange rate, yes, but like it's not influencing the rendering. And so let's profile this again, but first lower the price. And now change the exchange rate. And now it is re-rendering automatically. So you see that like, thanks to doing this runtime, this dependency analysis at the runtime, it's like even following any conditional logic you might have, any looping you do. And so if we would want to express this in like that custom comparison function we had earlier with Immutable Data, that would be pretty challenging. Like it would A, be a lot of work, and B, it's pretty likely that we break it in the future. So I think that nicely demonstrates why the model is superior. Now, if you paid attention to the demo so far, to the bottom part, you might have noticed that like if I change the exchange rate of one currency, all of them, the entire table re-renders. Now that's a bit stupid, but there's a clear reason for that. And that is basically because I'm rendering the entire currencies up here. So I'm rendering the entire currencies in one table. So it's all rendered by one component, and so the smallest thing you can re-render then is one component. So a super simple way to make this more efficient is by simply breaking it up in smaller components. So let's introduce a currency line component that takes the currency table. Remember that this is table constant reference and currently the currency we're interested in. So we map over all the keys in the currencies table and we call the currency line. So the only thing we did is now we split this into two components. And now we can try the same thing. We update one currency and what you see immediately is like the table doesn't re-render anymore, only the specific currency. So if things are not fast enough, you can always like break them down into smaller components. That means that like smaller parts of the UI are individually updatable and things will get faster. It's that simple. And finally, and I'm going to talk about this only really briefly, what I like about the separation I just made earlier, where I create those factory functions that create observables, is that it nicely decouples all my domain logic and state from my UI. So I don't like having too much logic in my UI for a few reasons. One is like if you have as much logic as possible in your domain code, it's easy to swap frameworks. Like you could use this MobX stuff in Vue or with LitElement or React just as fine. But that's not the interesting thing, because that's not the most likely to happen. But it also means that you can use this logic if you want to expose an API from the backend, for example. Like you can literally reuse the same code because the state is no longer owned by or organized by components. But what I like about this the best is testing. So the less wiring, less plumbing you do in your UI, the easier it is to test. So I see your API you have on your objects basically as another user interface, a programmable user interface you can use from your unit test. And so I talked about this quite extensively in earlier talks, but just to give a very brief idea about that, is that we can now in a unit test basically do the same thing as we did in our React components. We create an order store and we can do that per unit test because it's like super cheap. And we can create some initial data and we can immediately make assertions on it. And what I like about this is that like I express what the user is doing, like adding an order, and I can make assertions on it, but I can assert directly on the data and I can invoke the methods directly on the elements, and I don't have to assert it in the DOM tree, and I don't have to find the right button and then trigger an event on it to test this stuff. And that's nice, and the reason I can safely do that is because there's a little plumbing. So if you like have one unit test that like just make sure that like the event handlers got connected to the right methods, so you don't break that, and then you can test all your logic directly against your APIs you expose for your objects. So that's why I like using those factory methods and extracting all that logic. And so you can really take it very far. You can build view models and even model routing like this. But as I said, there's other talks about it. So, to conclude, with observable data, we know what changed and where that's relevant, and that's a big benefit. And that means that in the end result is that you have like quite straightforward code to read and write, and you get really smart, optimized rendering, which is a lot smarter, a lot better optimized than probably what you would do by hand. And it allows for easy separation of concerns as well. And so there's not just a bunch of individuals that believed in this model, because I think these are really cool examples of applications using MobX. So Battlefield, it uses MobX for state management and UI. And so does Outlook Web Access. It's heavily running on observables. And to make sure that like if you update the title of an email in one place, then the preview pane gets updated automatically as well. It's super neat. And there's many, many more products where you can find MobX if you enable the dev tools. So I think the cases where observable data really shines is when you have like very frequently updating data or very interactive data, or where you have like a lot of cross-cutting dependencies. So where one piece of data can be rendered in many places and you don't want to manually keep track of where it is exactly used. And it allows some architectural freedom. I showed you two quite different ways to organize a MobX code base. And so that's the flexibility it offers as well. And so with that, I want to leave you. Feel free to ask questions later. Thanks for your attention and see you later.
So while people are getting their questions into the Q&A area, and please do, everybody watching along, please pop your questions into Q&A for Michel. I'm going to ask you a little bit about the workshop that you're hosting on Wednesday with this conference. Would you like to tell us a little bit more about it and what people will learn if they take part?
Sure. It's going to be about TypeScript. And I think TypeScript has now become like the de facto type system in JavaScript. But what's usually hard to grasp when learning TypeScript is what is the bigger picture? How do it's a language with many, many different aspects, and like how do they all relate together? How do you go from idiomatic JavaScript to idiomatic TypeScript? When do you keep your types very strict, and when do you bend the rules a little bit? Like making it practical, like how you would run it in a big project. That's basically the question I want to answer, and like getting that mental picture of TypeScript basically complete.
Okay, so it sounds like it's not necessarily for TypeScript beginners, but people already using it. Is that right?
Well, I do go through the basics first, but I do that quite quickly. So if you did any static language, you can definitely join in. If you didn't do any TypeScript before, like the first 1-2 hours will be a little bit trickier, but you should be able to follow along still.
Okay, well, to anybody who wants to join in that, I believe there are just 3 tickets left, so go and snap them up quite quickly. It sounds like it's going to be an amazing session. So we've had a couple of questions come in, and the first one is, should I use MobX with or without decorators?
Good question. So when I originally developed MobX, it was like for TypeScript only, and TypeScript had decorators like 5 years ago already. And with the assumption that they like would soon be standardized. That didn't happen for the last 5 years. So at this point, I wouldn't recommend using decorators, especially if you get started. Like they do make the experience better, but like you need a more exotic build setup. So currently in the new version of MobX, we're moving away from recommending decorators as the standard way of doing things. They're still supported, but we don't promote them anymore in our documentation for that reason. And also a nice benefit from that is that it gives us a clean sheet in the long term. Why? Because like the standardization process is still ongoing. And like last week, basically a few days ago, a new proposal landed for TC39 to implement decorators. And so that means that like that we don't have any technical debt before we can start adopting it. So at this moment, I would recommend to not use decorators.
Okay, so no, don't use decorators. Leave them alone. You have got to paint your own house. I'm sorry, we're talking about MobX now, aren't we? So we've had another question come in. This one is about using MobX with something other than React. Are there tools available to use MobX on the front end together with something like Vue or Svelte?
Oh, that's a fun question, because like I was exactly Googling for that question today.
Perfect.
So it turns out that there's a lack of community maintained typing for both Vue and Svelte. So yes, you can use MobX in Vue or Svelte. That being said, I don't think it offers a lot of value, because like both Vue and Svelte offer a reactive tracking system, which is very similar to MobX. So the main benefit of MobX is that like it allows you to keep your reactivity system entirely decoupled from your UI framework. But beyond that, they basically offer a very similar model.
Okay, so yes, there are tools out there, but you have to figure them out.
Yeah, I think it's ourselves.
Awesome. So are there any cons of using MobX or reactive architectures in general? That's been another question from Eagle.
I would say not so much, but yes, there are a few. So one that is like not every application is like super suitable for it. So if your application is like super transactional and kind of has like a conceptual append-only system, like if you're building like a log analyzing application or something, then it doesn't add its value. It's mostly interesting for applications that are very CRUD intensive. So like you go changing records like we did in demo, or which are very visualized. So if you are doing applications like that have like drag and drop and that kind of stuff, that typically is hard to do without technologies like MobX.
Okay. So again, it's like we've said in other conversations that these things are all tools and it's about choosing the right tool for the right job.
Yeah, exactly.
Okay. So this one sounds like somebody wants to give you a hand. What is the best way to start contributing to MobX?
Just chime in on the issue tracker. There's always new issues being opened or new discussions. So I think there's a lot of PRs getting merged, which are not coming from me. So just start somewhere. That's perfectly fine. And otherwise, feel free to DM me.
Yeah. So it's a very approachable package for people to start contributing to then.
Yeah, I think so. At least that's what I hope. So if it isn't, then let me know.
Well, hopefully nobody will get in touch about the last bit and just want to get in touch, giving you a hand.
Exactly.
So we're running over now, but I think we've got time just for one more question because there is one here from James. How to decide MobX state tree or just MobX?
Yeah, that's a tough question. So honestly, personally, I prefer MobX of MobX state tree. So MobX state tree is basically a very opinionated implementation of the state management on top of MobX. So in my demo, I had like 2 different ways of using MobX, which both work. And like if you don't want to have like too much discussions about like how you organize things, and you want like a lot of features out of the box, like time traveling and serialization and that kind of stuff, validation, then MobX state tree is really great. But personally, those patterns are in my head as well. So doing those things by hand, I have a problem with it. So I usually stick to just MobX.
Okay. Again, tool for the right job. And we've had another late one come in. What is your opinion for hooks?
That's how to answer this. In relation to MobX or in general, I think in general hooks are like really cool. Yeah, I quite like them, especially how nice they compose. That being said, there's a few things I don't use them too much for. For example, complicated use effects or complicated deep renderings, because I think that's easier in MobX. So for example, if you use use effects, then you're like figure out the dependencies and make sure that you have like the dependencies right, or otherwise yes, in YL. And MobX already can determine that out of the box for you what those dependencies are. So for those kind of things, I typically still stick to MobX. But in essence, I think hooks are really cool, especially composability, like things like on use resize or something. That's really awesome.
Okay, and on that note, we will have to leave it there, Michel. I want to say thank you for your amazing talk. Apologies once again for getting your name wrong in every way we could have. And I want to give you a thank you from everybody watching who's used MobX and has saved them time, effort, and energy. So thank you for all the time you've put into it.
Thanks. You're welcome.